Hello friends, so in today's question, the mass of wedge capital M or shown in the figure is M and that of the block is small m. So this is the wedge with capital M and this is a block of small m. Neglecting friction at all places and mass of the pulley, calculate the acceleration of the wedge. The thread is inextensible. Okay, so there is no friction and we are going to find out what will be the acceleration of the wedge. So in this case, we say that let the wedge is moving towards right with the acceleration of small a. Okay, so we say that let wedge is moving toward right with acceleration a. Okay, so it is moving towards right with acceleration a. So the acceleration of block M with respect to wedge will be also a. So they will be moving with the same acceleration, but the only difference will be that the wedge will be moving in the horizontal direction, something like this, with acceleration a, whereas the block rather, will be moving along the inclined plane with the acceleration a. So the acceleration of wedge block M will be in this direction of a acceleration with respect to capital M. You can see it like this. This implies that the acceleration of block relative to the wedge is a, but along the inclined plane. Okay, but down the incline. Okay, so if this is the acceleration of the mass M, okay, so let us say this is acceleration of capital M and this is the acceleration of block M but relative to AM, so we can write this as A M comma M in the downward direction, and its value will be obviously equal to A. And if there is angle of theta, or rather there will be angle of theta between two, as this is an angle of inclination, theta is there. So from here we can find out the acceleration of the block in the respective direction. Okay. From here we can say that therefore the net acceleration of the block, net acceleration of the block will be the vector sum of the two, will be the vector sum of the two accelerations, the two accelerations, and these accelerations are nothing but am comma and the relative one. Okay. So we can divide this, the relative part of the acceleration, into two components, the vertical component as well as the horizontal component. So horizontal component will be coming as a cos of theta, and the vertical component will be coming as a sin of theta. Therefore, we can assign the velocity component of acceleration component of small block m in x direction will be equal to a plus a cos theta, and in the y direction we can assign it as AMY will be equal to a sin of theta. So we can say that, or rather we can write same thing here also. So AM in x direction will be equal to relative component in x plus of this will be x also, and if we put the respective values, we get this as a cos of theta plus a. From here we can write AMX equal to a 1 plus cos theta, and in y direction AMY will be equal to relative component in y direction plus AMY, and this will be equal to a sin of theta, and there is no y component of this wedge, so we are going to 0. So from here we can write that AMY will be equal to a sin of theta. Now we are going to draw the free body diagram. First of all, let us consider the wedge. Okay. We draw for the wedge. So this is the wedge having angle of theta, and its mass is given as capital M. So first of all, we are going to have mg, the downward direction, and there is a pulley, and we have tension T, and this will be also tension T. This T can be divided into two components. So we are going to have this as T sin of theta, and this will be T cos of theta, and there will be a normal because of block M, so let us call this as normal as N1. So this N1 will be also two components. This will be our angle theta, so this will be N1 cos of theta, and this will be N1 sin of theta. Okay. Yeah, I think this covers more or less everything, and it is moving towards the right with the acceleration of a. So you can see that for wedge free body diagram, for wedge, okay, I missed one thing, that is because of the surface there will be also a normal in the upward direction. Let us call that n2. So we can see that n2 is equal to n1 cos of theta plus d sine of theta, and there will be plus mg downward direction, and let us call this as equation number 1. Secondly, in the horizontal part we have t, then we have t cos theta, and we have minus n sin theta, n1 rather, n1 sin theta, and it is going to give us a ma. That is the question number 2. Now we concentrate on the block. Okay, so this is our block, mass m, so it is having a mg, and there will be a tension T. Those T can be divided into two parts. Okay. So we have T sin theta, and we have this will be our theta. So we have T cos theta, and there will be a normal of n1. So this n1 can be of also 2, theta, so this will be n1 cos theta, and this will be n1 sin theta, and there will be mg also. Yeah, I think this completes more or less everything. Yeah, mg is there, normal n1, yeah, everything is there. So we can say free body diagram for we have block M. We recount this as n1 sin theta, and we have minus t cos theta, and okay, and in this direction there is an acceleration of a1 plus cos theta, and in this direction it is having acceleration of a sine of theta. So we have t cos theta is equal to m a1 plus cos theta. Let this be question number 3, and we have mg minus n1 cos theta, and minus t sin theta is equal to ma sin theta, and let this be question number 4. Now using question 3 we can find out what will be the value of n1. Okay, using question 3 we get n1 is equal to t cos of theta plus ma 1 plus cos of theta divided by sin theta. Now we put this value of n1 in our equation. Okay, so we put this value of n1 in equation number 4. We write using equation 4, we get mg minus n1 is given as, we write first of all cos theta divided by sin theta, and we have n1 as t cos theta plus ma plus cos theta minus t sin theta is equal to ma sin theta. Now we open the bracket and we can further solve it now. You can see that taking the LCM of sin theta also simultaneously, we get mg sin theta minus t cos square theta, and this will be minus ma cos theta 1 plus cos theta minus t sin square theta is equal to ma sin square theta. We combine these two terms, t as well as t, and taking others on the other side, we can say that mg sin theta minus t, we have cos square theta plus sin square theta, and this we can just open the bracket, we get ma cos theta minus ma cos square theta is equal to ma sin square theta. So this we get cos square sin square is 1, and move toward other side, we get t is equal to mg sin theta minus ma cos theta, and this will be minus ma cos square theta and minus ma sin square theta. So we can combine these two terms, taking minus ma is common, so this will be cos square plus sin square, which will be equal to 1. So from here we can say t is equal to mg sin theta minus ma cos of theta, and this will be minus of ma. Taking ma is common, so we get t is equal to mg sin theta minus, one second, yeah, I think this is correct, minus 1 plus cos theta, so this is nothing but value of the tension, and let us call this equation number 5. Next, we are going to put this value of tension in our two equations. Okay, so we have already derived the equation. One of the equation is t plus t cos of theta minus n1 sin of theta is equal to ma, and the other equation is n1 sin theta minus t cos theta is equal to ma 1 plus cos theta. So we are simply going to add these two equations. So adding these two equations, t cos theta and n1 sin theta, these two cancel out with these two terms. So we get t is equal to ma plus ma1 plus cos of theta. This is nothing but addition. We simply add them, these two equations. Yeah. So from here we already know value of t, or we can use the equation which we found out, which states that t is equal to mg sin theta minus ma 1 plus cos theta. Okay, this is nothing but our equation number 5. Okay, this is our equation number 5, and t plus t is equation number 2. So this is our equation number 2, and n1 is our equation number 3. This is equation number 3. So we are going to equate these two equations from here, which you get as ma plus ma1 plus cos theta is equal to mg sin theta minus ma1 plus cos theta. So we are bringing this to here and taking a as common. Get a m plus, this is ma cos 1 plus cos theta, and this is minus ma 1 plus cos theta. So this will be 2 m 1 plus cos theta is equal to mg sin of theta. And from here we get the value of acceleration as mg sin theta will be equal to m plus 2m 1 plus cos theta. So this is nothing but acceleration of the wedge. Acceleration of the wedge. Thank you.